Hi guys, so we are moving on to section 2 of chapter 5. This chapter we have only two sections. So in section 1 we talked about addition and subtraction of integers, and in this section we are talking about multiplication and division. Okay, we are going to use models again. But this time I'm going to show you two different kinds of models. First one is chip models. We use red chip for negative numbers and yellow chip for positive numbers, right? So negative integers are represented with red chip, and positive integers are represented with yellow chips, right? So keep that in mind, and we're gonna use that. And another thing that we are gonna talk about here is putting in and putting out. So if you have a positive number, we are going to put in to a circle or that group, and if you see negative, that means it's take out. Okay, so I will introduce you how you can use that. So here's one example, positive 2 times negative 3. So we are putting in, because it's a positive, okay, we are putting in two groups of negative 3. So we are putting in two groups of 3 red chips. Okay, so if you see my picture here, I have one group of negative 3 and another group of negative 3. So I have two groups of negative 3, and I'm putting them in the circle, and we are counting how many there are. I have 6 red chips, which means 6 negatives, because each of them is negative 1. Okay, so that's what it means. Okay, we are going to talk about negative 2 times positive 3. This is a little bit more tricky because we have nothing in the circle. How can we take away? So negative 2 means take out of the circle, right? There's nothing. How can we take out two groups of 3? So let me show you something there. So okay, I think I can do it here. So here's an empty set that shows 0, but since we have to take out, there should be something. So if I have, let me actually use that negative here, negative 2 times positive 3. Okay, in order to show this one, I'm thinking about an empty set because, well, it starts from 0. We're gonna put in or take out. But since it's negative 2, we need to take out two sets of positive 3. Two sets of positive 3. But do we have anything? We don't. So let's think about making zeros. So there's nothing means it's 0. So I'm gonna use these two different colors, okay? So if I have one negative and one positive, it's compensating to each other, so that's same as 0. If I add another positive and another negative, it's still 0, right? They are compensating. And if I have another one red chip and put another positive chip there, it's still 0. So no matter how many red chips I put in, if I match that up with the yellow chips, it's still 0, right? So now I can take away two groups of 3, positive 3. So I'll actually have more than that, right? So if I continue that, if I have 6 positive chips and if I have 6 negative chips, it's still 0 because all of this can be paired up and cancelled out, right? So this is still 0, but I can take away two groups of 3. So I have one group of 3, I can take it out, right? So take out, this negative means take out. one group and two groups, I can take them out. Then what is left? These are taken out. So I have negative 1/6 of the chips left. So the answer here is negative 6. Okay, so I'm gonna show you that here. Okay, the same thing, right? This is still 0 because they are all paired up. They are all paired up. So that's 0. But since I need to show two groups of 3 have to taken out, right? I can take out two groups of 3 here, and what is left? Two groups of red. So negative 6 is left. That's how you can get that answer. Okay, I'm gonna give you more of them. What if you have to multiply negative 2 by negative 3? How can you represent that? Okay, let me draw the picture to represent negative 2 times negative 3. Okay, so we can start from the circle, right? Let me actually draw that here. Okay, so let me draw it. Okay, here is a circle, and we need to show negative 2 times negative 3, right? So that negative means we are taking out, take out what? Two groups of negative 3. Negative 3, so red chips, right? But we don't have anything, so we can make zeros there, but it says we have two groups of negative 3. So we have negative 1, 2, 3, but it says two groups. So if I have another group, that's not 0 anymore, right? So to make it 0, we need to compensate that with positive chips, the yellow chips. So now it's still 0 because all of these will be cancelled out, right? By matching them up. Now we can take out two groups of negative 3. So I have one group, let me use different color. One group of negative 3, take it out, and another group of negative 3, take it out. Then what is left? These are taken out. What is left? I have positive 6, right? 1, 2, 3, 4, 5, 6, positive. So it is 6. So we can get to know negative 2 times negative 3 is positive 6. In the previous one, we did negative 2 times positive 3 as negative 6, right? Then we can continue doing the same thing. What if we are doing 2 times positive 3? We already know how to do that. How about 2 times negative 3? I'll need to think about that. So if we are multiplying by negative 2, that means it's taken out. But positive 2 means we are putting in, we are adding, putting in two groups. Put in two groups of positive 3 and two groups of negative 3. So that is so much easier to draw, isn't it? So to show this part, 2 times positive 3, you can just put in two groups of positive 3. So we have two groups of positive 3. 1, 2, 3. One group of a positive 3 and another group of a positive 3. And what do we get? That is 6, right? And also we can use chip model for this representation. We are putting in, put in what? Negative 3. How many negative 3? Two groups of negative 3. So negative is red chips. We are putting in two groups of negative 3. One group of negative 3 and another group of negative 3. 1, 2, 3, 1, 2, 3. So we put in one group and two groups of negative 3. What is there? Well, that's negative 6, right? So we can get to know that's negative 6. Now we can generalize that by looking at this, right? We have negative times positive, that's negative. we have negative times negative, positive. Positive times positive is positive. Positive times negative is negative. So what can you conclude? Well, we cannot conclude by just looking at only few examples, but we can do all of them and can have the conclusion of if you have any positive number times positive should be positive. If you have a positive times negative, that's negative. When you had negative times positive, that was negative. When you had negative times negative, that is positive. So we can conclude that. Okay, and that's gonna be the rule that we are going to talk about. So this is what I have explained earlier. So negative 2 times negative 3, you are taking out, it is because it's negative, taking out two groups of negative 3. But since there's nothing, we need to make it 0, still 0. So this makes 0. Now we can take out because there are something in it, right? So we need to take out two groups of negative 3, two groups of red chips, 3 red chips, right? So what is left? Positive 6. The yellow ones are left, right? So we have negative 2 times negative 3 is positive 6. We can also use the number line model to show the multiplication. For the positive integers, we already know that, right? So 3 groups of 4. So we are jumping 4 to the right. How many times? 3 times. So we jump 1, 2, 3, 4 one time, another 1, 2, 3, 4 second time, and third time 1, 2, 3, 4. Where do you land? 12. That is the product of 3 times 4. How about 3 times negative 4? So the first number here is showing the direction of the same thing. If it's a negative, we're gonna reverse it. Okay, so the opposite direction. So this one, it says same direction as the number next one, 3 times. So we're going to the negative 4, which means we're going starting from 0 and go to the left by 4 with the same direction because it's positive. Keep going on to the left 3 times. So this is what's happening. Starting from 0, we go to the left by 4. How many times? Same direction 3 times. Okay, and where do you land? Negative 12. So that shows the same direction or opposite direction, and that is the number right or left. Okay, so here's another example. If we are doing 3 times 2, we know that we are moving to the right by 3 times, and each jump you have 2 jumps. So we have 2, 2, and 2. Right? We are adding 2 3 times. If we are doing 3 times negative 2, we are adding 3 negative 2 negative 2 and negative 2 negative 2. So we are adding negative 2 3 times. Right? That's the same meaning here. Negative 3 times 4. So we are going to the right by 4 if we have only 4 times 3. But it says negative, which means it's the opposite direction. So it's not going to the right side, but it's going to the opposite side, to the left. So we need to go to the left by 4. And how many times? 3 times. Okay, how about this one? We're going to the opposite direction of the negative. So what's the opposite direction of the negative? Positive direction. So you will go to the right. How many times? 3 times. And each one has 4 there. So yes, it's gonna be represented as this one. So it's supposed to be positive 4 if it's not negative, but it says opposite direction. So instead of going to the right, you go to the left. 3 groups of 4. Okay, this one, if you have positive 3, you will go to the left hand side, but it says it's opposite direction. So you are not going to the same direction but opposite direction of -4. So you are actually going to the right by 4. How many times? 3 times. So starting from 0, you go to the right 3 times, and each skip you have 4 steps there. Okay, so you can use that one. You can also use the pattern. So we're gonna look at the pattern. If we have patterns like this, 5 times 4 is 20, we're doing 5 times. So all the natural numbers and 0 whole number, and then you can extend that to negative number. Then what's happening? Let's see. From 4 to 3, when you are changing the factor by reducing that by 1, what's happening here? The product is decreasing by 5s, right? If we continue that pattern by decreasing by 5, decrease that by 5, what's 5 minus 0? That's 5. What's 0 minus 5? Has to be -5, right? And then take away 5 more, -10. So we can say that 5 times -1 is -5, 5 times -2 is -10. It's kind of a tedious procedure. So thinking about 5 times -100, we're gonna keep going on and on and on. So using the pattern is for more primary level, but it works. Okay, so same for this one. What's -3 times 3? It's -9. -3 times 2 is -6. -3 times 1, -3. If we continue that, keeping the first factor as it is, but changing the second factor by reducing by 1, what's happening? We are adding 3 each time, right? We are adding 3 each time. So the next number will be 3 more to 3, which is 6. So we can get to know that -3 times -2 will be +6. And then 3 more, 9. -3 times -3, +9. Okay, that's when we are using the pattern. Okay, let's use the rules now. Okay, now we know this following rules. -1 times a is -a. Without negative, 1 times a is a, but we have negative there. So -1 times a is -a. Negative times negative will be positive. So when you have the same sign, you have the positive product. Different sign, you get negative. Okay, and we already know that multiplication over addition, we can have the distributable property there, right? So we can do a times b, if it's plus a times c. Similarly, we can use that for subtraction too. And if you guys remember, I have said that subtraction is same as addition of negative numbers. So yeah, we can use that distributive property for that one too. Even if you have a is multiplied at the end of the parentheses, we can still distribute a to each of these terms. B times a minus c times a. We can do that. Still the same thing. Okay, so using all the rules, I'm pretty sure you can solve these problems. So pause the video and solve the problems and come back. In the meantime, I'm going to bring the Jamboard there. Okay. Oops, I have to do it the other way. Alright, so we have a -3 times x minus 2. In b, we have a plus b times a minus b. Maybe some of you already remember this from your high school. Okay, anyways, we see that -3 is multiplied by x minus 2. So x minus 2 is a whole quantity. So we cannot separate them like this, right? Because we have to do in the parentheses first and then multiply. But using the distributable property over subtraction, we can distribute -3 to each of the terms. Then the answer is still same. Okay? So negative 3 times positive x, negative times positive, negative 3x, negative 3 times negative 2, negative times negative, positive 3 times 2, 6. So it's gonna be negative 3x plus 6. How about this one? We have two terms in each parenthesis. So you need to distribute a to each of the term first and get a times a squared, a times b, ab. What's the sign? Positive times negative, negative. Now you need to distribute b to each of them. b times a, ba. ba is the same as ab using the commutative property in multiplication, right? So can I just write it as ab? Same thing, ba. And we have b times negative b, positive b times negative b squared. So what happens? These two are cancelled because negative and positive with the same number is 0. So we have left only a squared and minus b squared, right? And so if you see this one, you can factor back to a plus b times a minus b. Okay? So that's what it is, and let's look at the next question. Okay, so we can still use the difference of square formula. Okay, so now we have learned this, right? So a plus b, same number, but the addends has changed from plus to minus. Then you can do a squared minus b squared because inside will be cancelled out. So knowing that, using that, you can solve these problems. Okay, so the first one is 4 plus b times 4 minus b. So again, we already know that a plus b times a minus b is a squared minus b squared, right? If you have the same number, a and bb, but a is the same, but b, you need to change the sign, then inside it will be cancelled out and leaving only a squared minus b squared. Okay, so this is exactly same thing. What's your a here? 4. So that answer will be 4 squared. And what's b? Still b. b, positive b and negative b, so minus b squared. Or you can say that's 4 squared, 16 minus b squared. Same thing. Okay, let's look at b. Negative 4 plus b times negative 4 minus b. So let's compare this again. Hey, that's negative 4 and negative 4. So your a this time is negative 4. So your a is negative 4. So a has to be squared. You need to put that in the parentheses because negative 4 squared is not same as negative 4 whole thing squared. This one, 4 is only squared, so it's gonna be negative 16. But this one is negative 4 times negative 4, so it's positive 16. So they are not equal. So you need to be very careful when you're squaring or even powering for negative number. Okay, so you need to do the whole thing. Negative 4 squared minus what's b? Still b squared. Negative 4 whole thing squared is positive 16 minus b squared. So these two are same answer, even if the question is different, right? Okay, and let's go to C. C. X plus 3 squared minus x minus 3 squared. So I see something is squared minus something is squared. So we have this form, right? But what is my a? This is squared. That is squared. So that's my a and that's my b, right? So I can have this plus that in one parenthesis, and on the other parenthesis, this minus that, right? So if I do that, I know x plus 3 is my a and that's my b. So I can add a and b together, plus x minus 3. That's it in one parenthesis. And on the other parenthesis, I have a minus b, right? So x plus 3 minus, again, you need to make sure you put that in the parentheses because you are taking away this whole quantity. If we simplify this, what happens? It's x plus 3 plus x, so we have 2x plus 3 minus 3. It's gone. How about here? We need to simplify a little bit more, so let's do that. Because this is multiplied by negative numbers, so we're going to distribute negative to each of them. And I have negative x, negative times negative, positive 3. Okay, now we have 2x from here, so 2x times, what happens here? X and negative x will be cancelled out, and I have 6 there, 3 plus 3, 6. So I see 2 times x times 6. 2 times x times 6. I can use the combinatorial property there, so I have 2 times 6, 12 times x, 12x. Okay, so that is the answer. We have one more example, I think, on the next example. Oh, no, not really. We have division in the next problem. So, oh, actually we have one more. Oops. So, let's talk about that in a minute. I want you to solve these problems first. So this is the other way around. You are given a squared minus b squared. So you want to use a squared minus b squared can be factored as a plus b times a minus b. Okay? Once you solve it, come back. Okay, so let's solve these problems together. Okay, so I already copied them down. So we are going to factor x squared minus 9. We already know that a plus b times a minus b is the same as a squared minus b squared, right? So if we are given any form of something squared minus another thing squared, we can change that to plus, minus, and product of those two, right? So we can think about this problem relating that to this type of problem. So as you can see, x is squared. Oh yeah, it is very similar. And minus, okay? 9 is something squared. What is squared? 3 is squared, right? So we can rewrite this as x squared minus 3 squared. So here I can see that, oh, my a is x, right? A is x. So I can change that to a plus, x plus, because our a is x. Come on. Okay, so we have x plus and x minus in the parentheses. Now, what is my b? What is squared? 3 is squared. So you can add 3 in the first x, and you can subtract x on the second x. Okay, so that's what it is. You can always check your answer by distributing this back and get that one, right? So to check, you can just do x times x, x squared, x times negative 3, negative 3x, 3 times positive x, positive 3x, positive 3 times negative 3, negative 9. And what happens? These two will be cancelled because it's 0. So you have x squared minus 9. So yes, we checked it. Answer is correct. So you can say that then this answer is right. Okay, so we factored it. Okay, let's do the same thing here. As you can see, something is squared and another thing is squared. Very similar to this one. So what is my a here? This time, this whole thing is my a. So we can get to know x plus y is added by something and x plus y is subtracted by something. So what goes here? What is squared? This is squared. Z is squared. So you can just put z in it. Again, you can always check by distributing that again. This is a little bit different story because nothing is squared here. So it's not the form of that. For problems like this, you can see each term. So before I look at something as squared minus something squared, I'm going to look at each term and see whether any factor is shared. So any common factor exists between those terms. So for this one, nothing is in common, right? X is squared, 3 is squared, so there's no common factor. You're gonna examine these two factors and see, oh, here's an x multiplied to negative 3 and x is multiplied to 5 and 5 times y. So yes, I can factor x out of negative 3x. So you can go backwards, okay? So when you distribute x to negative 3, you're gonna get x times negative 3, which is negative 3x. I got it. And to get 5xy, what do you need to multiply? 5 and y, right? 5 times y. If you multiply these two together, you're gonna get x times 5y, x times 5y. In multiplication, we can use commutative property, so that's same as 5 times xy. Okay, we usually write the number first, then in alphabetical order of the variables. So yes, we are done. So we can factor x out, and what do we have? Negative 3 plus 5y. To check your answer, you can always distribute the factor to the terms that was not factored out. So x times negative 3, negative 3x, x times 5y, 5xy, I already showed you right here, so 5xy. And I see these are exactly the same thing. So yes, my answer here is correct. Okay, so that's what you can do. Okay, so we are done with factoring completely. Okay, now let's take a look at this. Integer division models. So we're gonna talk about integer division this time. Previously we did a multiplication, and we also know the relationship between why is that there? Okay, oh, I think I need to I need to erase that part. Hold on. Okay, so let's talk about division now. Okay, you're gonna relate multiplication to division because we already have talked about this in whole numbers. So the definition of division is exactly the same as what we talked about whole number division. We are just extending the numbers to the integers. Okay, so we have a and b that are integers, then a divided by b is the unique integer c. So c is the quotient, a is the dividend, b is the divisor, right? And there should be no remainder because we're talking about only integers, not the rational number or real numbers. Okay, so if there's a unique integer c when you are doing the division that exists, then we can have the relationship there. Dividend is the same as divisor times quotient. A equals b times c. If such a whole number a or integer c does not exist, then a divided by b is undefined. Okay, so let's take a look at the examples. You can use the definition of integer division using that multiplication there. So dividend can be calculated as divisor times quotient. So let's think about these problems. Okay, the other way. Okay, so I copy them down here. You wanna use the definition of integer division. If possible, if there is no such integer, you can say it's undefined, right? So let's look at the first one. We have the first problem here, 12 divided by negative 4. So to find the quotient for that, we can think about the definition of division. So 12 is the dividend, that is equal to negative 4, the divisor, negative 4 times something. That something will be the quotient. Is there any integer? Is there any integer that is multiplied by negative 4 and gets 12? Yes, right? So negative 4 times negative 3 will be positive 12. So yes, there exists an integer that makes this statement true. So the quotient is negative 3, right? We can do the same thing using the definition of the division in integer to solve for negative 12 divided by 4. Let's say negative 12 divided by 4 is something, let's say quotient q, then what's the relationship there? The dividend is from divisor times quotient. So 4 times what makes negative 12? Well, you can think about 4 times 3 is 12. So to make negative, you can say that should be negative 3. Or maybe you can think about negative 12 divided by 4 as this, right? So 4 times what makes 12? 3, but it's negative, so it's negative 3. Okay. Later on, we're gonna apply the rules of, positive times positive is positive. So similarly, positive divided by positive is positive. Positive divided by negative is negative. Negative divided by positive is negative. Negative divided by negative is positive. We can think about that too later on, okay? But now we're just gonna use the definition of integer division. So let's continue. C. Negative 12 divided by negative 4 will be something, that quotient. And we also know the relationship between these three numbers, right? So dividend equals divisor, it's not writing correctly, times quotient. So negative times 1 makes negative positive. So we know that q will be positive number. And 4 times what makes 12? 3 does. So q should be positive 3. So that is positive 3. And what did we get here? Negative 3. Okay, we can continue that. So D, negative 12 divided by 5. Negative 12 divided by 5 in integer. What is that? So we can say that's a q, and we are still looking for q. And negative 12, the definition of division, the negative 12 dividend is divisor times quotient. 5 times what makes negative 12? No integer does. So there's no such integer for that one. So there's no integer. Why is not writing correctly? I don't know. No integer to make this statement true in the integers, right? Yeah, because we know that 5 times something will be always ending with 5 or 0, but this one has 2 in the ones place, so it's not divisible by 5. So we get to know that, so it is undefined. Well, it's different from undefined actually. We can just say that there's no integer quotient. Okay, no integer for that. How about E? AB divided by B, where B is not equal to 0. So let's use our definition of the integer division again. So the dividend is A times B is equal to B times what? B times, somehow it's not writing correctly, sorry about that. B times something, that something will be the quotient, right? Because B is the divisor, AB is the dividend. Dividend equals divisor times a quotient. So you need to fill up this part. AB is B times what? Yes, A, because AB is same as BA using the communal property of the addition, multiplication. So in that case, it's an A, and of course A is also an integer. So A is an integer. Okay, let's look at F. So let's use our definition of division again. AB is the dividend. Dividend equals divisor A times something, that quotient. What could be the quotient? Yeah, AB is A times B, and B should be also an integer. So in this case, B, where B is also an integer. Okay, sorry for my writing here, it's not really good today. I don't know why it's not working. Okay, anyways, we got them all. Okay, and I have explanation here too. We can talk about the ordering integers. So we know that we can use the number line. That's the most efficient way, I think. And when you have a number on the right hand side, it's greater than left hand side. So compare, for example, -1 and -5. Even if the absolute value of -5 is greater because it's farther away from 0 than -1, but it's on the right hand side, so it is a greater number. So just like positive numbers, when your number is on the right hand side, it's always greater. Okay, for the left, you're gonna have the smallest number there. So we can compare -10 and -1. -1 is here. Where's -10? -10 is farther away there on the left hand side, so it's much smaller than -1. Compare -5 and -4. Well, -4 is greater, even if the absolute value of that for 5 is greater, because -5's absolute value is 5, absolute value of 4, -4 is 4, but actual value here, -4 is greater than -5. Okay, so you need to know how to compare those numbers. And let's talk about the rules here. Okay, so definition of less than for integer. For any integers a and b, a is less than b, so we write it this way: a is less than b if and only if there exists a positive integer k such that a plus k equals b. So there's always a difference between a and b, and that much difference makes a is smaller than b. Okay, so there is always positive integer k. Okay, if k is 0, they're gonna be equal, so it doesn't work. If k is negative, you're gonna have a minus something, some number, right? So then b is not always greater than a, so k has to be a positive number. Okay, and look at these theorems. If x is less than y, and n is any integer, then if you add the same number, whether it is a positive integer or negative integer, you add that on both sides, then inequality doesn't change. Okay, so you can think about the balance beam. Okay, this side, left hand side, is already greater, so actually let me pull out my Jamboard here and talk about these theorems. Okay, so theorem, I copy down the theorems here, and let me I'm not a good I'm not a good artist, but I can try. Okay, so the first one here, if x is less than y, again, x and y here are integers, and n is also any integer. Okay, so x and y, there's relationship. X is less than y, which means y is heavier. So let's say x is lighter in the scale, so it goes like this, right? And y is heavier, so it goes down in the scale. Does it represent y is heavier? Okay, so we are adding certain number there. Let's suppose n is a positive integer. So you are adding exactly same amount there on both sides. Then still this side is heavier. If n is negative integers, what happens? It's something like you are taking away a natural number there. So you are taking away that much from both sides. Then what happens? Still this side is heavier, right? So when you have an inequality like that, even if you are adding certain number on both sides, exactly the same amount, still the same inequality. Even if you are taking away same amount on both sides, still the same inequality. That's what it means. For example, we know that 2 is less than, let's say -2 is less than 1, right? Because it's negative, it's less than 1. If you are adding same number on both sides, it's still negative 2 plus 3 is 1, 3 plus 1 is 4. Still right hand side is heavier. Okay, even if you are adding negative number on both sides, what happens? Negative 2 minus 3 is negative 5. 1 minus 3 is negative 2. Which one is greater? For negative number, small absolute value number is greater because it's on the right hand side. Negative 2 is there, negative 3, negative 4, negative 5 is here. So this is greater than negative 5, right? So it works. How about for number 2? Here, x is less than y. Then what happens when you have negative numbers? So let's give an example. I can give you some examples like positive numbers only first. 2 is less than 3. Then if I multiply negative on both sides, I have negative 3 and negative 2 and negative 3. Which one's greater? Which one's on the right hand side? Negative 2 is. So you are changing the sign, right? So I just explained with positive numbers only. Let's look at some negative numbers like negative 2 and 3. 3 is greater than negative 2 because it's positive, right? If I multiply negative 2 by 2, by negative number, then it's gonna be positive. And think about negative 3. Which one's greater? Positive number is greater, right? So it happens again. It's flipped again. Let's give another example like negative 3 and negative 2. When both numbers are negative, which one's greater? Negative 2 is greater. But opposite of that. So 3 and 2, compare them. What happens? 3 is greater. So we are flipping that again. So whenever we multiply negative on both sides, negative 1 actually, negative 1 on both sides, what happens? We are flipping the sign to the opposite. That's what it means, okay? And the third theorem here in 510 is x is less than y and n is positive number, then we are keeping the sign. So we are keeping the inequality if it's a positive, if we are multiplying positives, okay? But if you are multiplying negative integer, then we flip the sign. We flip the sign as shown here. Okay, that's what it means. So knowing that, I'm pretty sure we can solve the problems. If I have any question, I don't have any more examples there. So yeah, I'm pretty sure you can solve the homework problems. And if you have any question, please let me know. Thank you.